And now I'm happy to introduce Dr. Eva Unternaehrer. She became a PhD on psychosocial stress and epigenetics at the University of Basel, and has been a postdoc at McGill University in Canada and at the University in Constance in Germany. And she will speak about maternal caregiving, breastfeeding, and DNA methylation. Welcome, Eva. I hope you're there.
Thank you. So, well, first, thank you a lot for inviting me to give this talk and also talk about some of my own data, but also maternal caregiving, breastfeeding, and DNA methylation. And so here is what I'm going to talk about. So first of all, I want to, maybe this is some repetition, but I think we cannot stress this enough. Why is paternal behavior important? Or parental behavior, maternal, paternal, whatever. Why is it important? Then I want to talk a bit about maternal caregiving and DNA methylation. We have already heard of some of the studies that have been conducted. Then continue with maternal caregiving, breastfeeding, and DNA methylation. And a short outlook, where do we go from here? So why is parenting behavior important? Well, first of all, we all know that parental behaviors are a combination of different behaviors that really are there to ensure survival of the offspring by providing safety, nutrition, and warmth. And it's actually a really conserved behavior. So it's not only, we not only see parental behaviors in humans, but also in birds, in other mammals, and also other animal species such as spiders. So here you see a picture of a spider that is carrying a lot of babies. So when I started to examine parenting behaviors, which is basically my background, I was really, it got pretty clear to me quickly that it's not that simple like this graph does make believe. So there's not just like 4 types of parents, right? This easy model really quickly became a model that looked more something like this. And this is like I tried to make a mind map of all the factors that are associated with maternal parenting behaviors. So of course we have environmental factors, but also we have offspring factors that affect maternal parenting behaviors, and also maternal characteristics such as her biology, affect mood, attitudes, but also of course breastfeeding is a very strong component of maternal parenting behavior. So on the other hand, parenting or parental caregiving also has this dual role that we also heard in the previous presentations, such that it is, on the one hand, it is a protective factor if there's a lot of support and care, but it is also a risk factor if it's not there, or on contrast, if the parents are abusive to a child. And in this case, it can really also threaten physical and mental health. So this is also a bit what we see here in this pyramid, where at the bottom you have these adverse childhood experiences, and the low levels of parental care certainly is a part of these adverse childhood experiences, which affect neurodevelopment with consequences for social, emotional, and cognitive outcomes, behavioral problems, disorders, mental and physical disorders, as well as early mortality. And so for parenting, this really, one also needs to consider that parenting is not restricted to the first couple of days or months or years of life, but often it's a lifelong relationship that we have with our parents. And for example, when we become parents ourselves, the support of our parents is really important to giving us social but also emotional support. So here we see some child welfare statistics from Switzerland. I didn't have these data for Sweden, but since Americans always confuse Sweden and Switzerland, I thought, well, if I don't say anything, then they will not notice. But now I said it, right? Okay, so, but anyway, we see here the distribution of the different kind of adverse experiences that children can make during their childhood. And we see here that physical abuse and emotional abuse contribute about 50% of cases, and then also neglect is about 1/4, and then sexual abuse. But I think what's even more disconcerting is that more than 3/4 of these experiences occur in the child family environment, and more than 60% of the affected children are less than 1 year old. So to summarize that, I think that parental caregiving is a factor that is highly relevant when looking at child development and health trajectories. And the sooner we can support parents in providing this kind of safe, nurturing environment, not only on a physical but also emotional level, the better. So what are the consequences of high quality parental behavior? Well, on a behavioral level, it is associated with infant attachment. So infants or children of high caring parents have a more secure attachment. They have better self-regulation, higher cognitive socio-emotional development, and have a lower risk for physical and mental disorders. On a neurodevelopmental level, we see differences in brain development, then also the stress axis, the sympathetic nervous system, but also a lot of other biological systems. So the list here would basically be endless, right? And we already heard in the previous presentations on some of these components. And that, of course, then brings us to the molecular level and the epigenetic programming by maternal behavior. So in sum, we can say that parental behavior is complex, but it is an important factor that shapes child development and also neurodevelopment. So, but how is maternal caregiving associated with DNA methylation? This is kind of what was promised by the title of my talk. So we want to zoom in on this a bit more, of course. So for me personally, this is really kind of a backward history of whys. And I'm sure that Patrick's going to talk about this a bit more in depth after my presentation. So I guess the success story of this behavioral epigenetics really started with a behavioral observation, namely that rat pups that received low maternal care, as measured by levels of licking, grooming, and archback nursing, these low care offspring has showed a higher fearfulness, higher stress reactivity, and was also lower caring mothers themselves when they themselves had offspring. So, but why would we see these differences? And so researchers found that in the rat pups that received high licking and grooming, there were more glucocorticoid receptors in the hippocampus compared to low licking and grooming offspring. And this was actually caused by also reduced expression of the glucocorticoid receptor gene. And finally, they found that this expression was changed because DNA methylation of a promoter area in the glucocorticoid receptor gene was reduced in those with high levels, or in those rat pups that received high levels of licking and grooming and ARTPAC nursing. So this has now also been translated from animal models to humans. And here, of course, we cannot look, or usually we cannot look into the brains of living humans, but I need to look at peripheral tissue. So many of these studies have been conducted in blood or other peripheral cells. And so what's interesting, a lot of these studies have focused on the early life environment and early life adversity, early life stress. And many of these studies have also looked at factors that are associated with the parenting environment. So for example, abuse by parents or parental neglect or death by a parent or of a parent, and institutionalization. So a problem arises when we look at, well, not necessarily a problem, but an issue, let's call it an issue that arises when looking at maternal care. We see that there is not only natural variation in maternal care, but there is also variation in maternal care as being used as a predictor for offspring DNA methylation. So here is basically most of the operationalizations that I have found in the literature, from harsh parenting, negative parenting, extreme insensitivity, maternal stroking, maternal rejection, supportive parenting, maternal structuring, protective parenting, or retrospectively reported maternal care, as well as sensitivity. So we see that there are different components, it seems, but of course, we assume that these are also highly correlated with each other. On the other side, there is also variation in the theoretical models that these studies assume. So, for example, a couple of studies look at the direct association between parenting and DNA methylation. So, for example, how maternal care affects DNA methylation of the glucocorticoid receptor. Some other studies also take a mediation kind of framework where they say, well, we assume that parenting is changing DNA methylation and that this in turn has an effect on child outcomes. So for example, low maternal care increases DNA methylation of the glucocorticoid receptor, and this increases the risk for higher stress sensitivity or higher risk for depression. And finally, there's also studies that take this moderation approach where parenting is assumed to have an outcome or an effect on child outcome, but only in a group of individuals that, for example, has high methylation in the glucocorticoid receptor. So we see there's different theoretical frameworks that are being assumed when looking at these studies. But of course, there's further differences that can be mentioned. So for example, study design, we now have indication for association between maternal care and DNA methylation in offspring through cross-sectional studies. So these are studies that are just looking at one measuring time point. We have longitudinal studies that kind of take this more long-term perspective. For example, maternal sensitivity in the first year of life, and then the link with DNA methylation when the child is older or even adult. Then there's also now very few interventional studies, but I think this number will increase in the near future. So then there's also different targets that you can look at. We came across a couple of different candidate genes mostly, but nowadays we also have these epigenome-wide approaches where we can, similar to genome-wide association studies, we can perform epigenome-wide association studies looking at thousands and thousands of CpG sites across the human genome. And there's also summary measures as, for example, the epigenetic clock, which is basically an algorithm that you can use to estimate biological age based on approximately 350 CpG sites that are measured in these classical microarrays that we know today. Then there's also different tissues, of course, and Agnes mentioned that different tissues, of course, have different methylation patterns, and it's what makes them different. So studies have looked at peripheral blood cells, including lymphocytes, buccal epithelial cells, saliva, but also cord blood. And finally, also population can be considered. So some studies have looked at effects in adults, some in children or adolescents, and or in infants and toddlers. So in sum, we now have evidence that parental behavior is associated with DNA methylation of candidate genes, but also very broadly in offspring. And I think these differences between studies are really not a disadvantage, but an advantage, because they are all little pieces in a puzzle, and once we put them together, hopefully we'll get a more complete picture. But of course, it makes comparison between these studies more difficult. So another point that I would like to raise is that we have seen that there are many different kind of measurements of maternal parenting behavior or maternal caregiving, but very few of these studies actually consider multiple components of maternal caregiving. And this is why, together with Wibke Jonas, we wanted to look at maternal sensitivity and breastfeeding as predictors of DNA methylation in offspring. And this study might remind you a bit of the Harlow experiments, where the baby monkey had the chance to either spend time with a wire mesh mother who would provide food, or this cuddly, fluffy mother with large eyes. And most of the time, the monkey would stay with the fluffy mother, and only for feeding would go visit the other one. But you can see it's like the baby monkey is very hesitant to do so. So for maternal sensitivity, I have chosen the definition of Mary Ainsworth, and she sees maternal sensitivity as a mother's ability to accurately recognize, interpret, and respond to her child's cues. And when we look at breastfeeding, it is important to note that, of course, a mother's milk contains macro and micronutrients and immunoglobulins, beneficial microorganisms, growth factors, and hormones, all of which promote child healthy development. And also the WHO states that exclusive breastfeeding for the first 6 months is the best for babies everywhere. So I tried to list here the previous research that has been done looking at some indicators of maternal care. And as I mentioned before, the list here is pretty long. However, these studies have found that different indicators of maternal care are associated with DNA methylation on an epigenome-wide level, but also with the epigenetic clock, so with epigenetic age acceleration. And many studies have also taken this candidate gene approach, where they looked at the glucocorticoid receptor 11 beta hydroxysteroid dehydrogenase, and FKBP5. So these 3 genes are strongly involved in the HPA axis, or in the primary stress axis. Then we have the serotonin transporter and serotonin receptor that are part of the serotonergic system that especially Rosario has also talked about this. Then the oxytocin receptor and brain-derived neurotrophic factor. So oxytocin, the kind of bonding hormone that you might all know for its effects on contractions during birth, but also lactation. Brain-derived neurotrophic factor is a neurotrophin, so it is involved in neuronal plasticity. And then TNF-alpha, tumor necrosis factor alpha. So maybe I go back. So I didn't list all the citations here, but I think there's 2 really good reviews that I can recommend if you are interested in reading more about these effects by Crate and Provenzi. And so I guess some of these names on the author list will look familiar to you. So I just want to quickly talk about one study that we did in 2015 that was on retrospectively reported maternal care and DNA methylation of BDNF and oxytocin receptor, for which we found that higher DNA methylation in a target sequence of BDNF and one target sequence in oxytocin receptor was increased in adult participants reporting low levels of maternal care. So this was a retrospective measure of maternal care, but still we did see these effects. So for breastfeeding, as you can see, there is less research that has been done so far, but breastfeeding, and here also again different approaches have been taken. So we see here exclusive breastfeeding versus any breastfeeding, and then status at the given time point versus duration of breastfeeding. And breastfeeding so far has been associated with different sites across the epigenome, but also with candidate genes, including glucocorticoid receptor that you might know by now, the usual suspect, so to speak. But also leptin and retinoid X receptor alpha, which are both involved in metabolism and hunger inhibition, and toll-like receptor 1. So for this study, and I think I will talk now a bit more in depth about this one study, because I think it complements the previous presentations by going into one study a bit more to kind of illustrate the process of epigenetic studies on the epigenome-wide, the taken epigenome-wide approach. So data for the study comes from the Maternal Adversity, Vulnerability and Neurodevelopment Project, or short MAVEN. So this was a study that was conducted in Montreal and in Hamilton, and was a collaboration between the University of Toronto and McGill University, where I did my postdoc. And so this was a cohort study that recruited pregnant women. And as you can see here, recruitment was from 2003 to 2009. So I think all in all, there were over 700 children included in this study, but of 229, we had buccal cell samples that we could use for DNA methylation analysis using the Illumina 450K array. I will talk about what this is in a minute. But also we used these samples for genotyping to get a measure of population stratification. So this is basically the genetic descent of of these participants to get an idea about their ethnicity. Then maternal sensitivity was measured at 6 months using the maternal behavior Q-sort. So this is an instrument where we observe maternal behaviors, and we have a set of cards and we sort them. And from this sorting, we can derive a score that ranges from -1 to +1, with -1 indicating low maternal care and +1 or low sensitivity, and +1 high sensitivity. Then we had also assessed breastfeeding status at different time points, and of course various covariates, including demographic variables, birth parameters, and others. So, but what is this Illumina 450K array? So when we look at DNA methylation, we can either study on the single CpG level, or maybe a couple of CpGs. We can also take this candidate gene approach, where we look at multiple CpG sites located on a particular gene of interest. But we can also look at we can also look at this on an epigenome-wide level. So, and I'm sorry I stole this picture from Agnes' presentation this morning. So Malin Wipke owes you coffee, okay? So how does this work? So we collected DNA from buccal samples and extracted this DNA. So it's basically a swab that you use, and you put it in your mouth and you kind of collect the samples. Then you do a bisulfite conversion and you run this microarray, which was the 450K array, which measures for over 450,000 CpG sites across the genome. And nowadays we even have more. We have the EPIC array, which runs over 850,000 CpG sites. You then extract the beta values, pre-process the data, and subject these to downstream analysis. And maybe we were talking, or Livio was talking about how family relationships and parenting behavior is messy. And this data is pretty messy too. So we need a lot of pre-processing to kind of get a nice readout. Okay, so here's just some basic demographics. I think I will skip over this one. Maybe the children were 4 to 11 years old, the mothers 18 to 43, and the birth size percentiles range from 0 to 100, with a mean of 46, so a bit lower than 50. So here are some more demographics we had about equal sex distributions. Then we had a couple of mothers who reported prenatal smoking, and about 84 or 37% were lower than the cutoff for low income in Canada, which is pretty representative of that geographic area. Here we see the distribution of the breastfeeding durations. So we have about the same amount that of participants who reported almost we had 60%, almost 60 participants who reported less than 3 months and 3 to 6 months, and then about almost 80 that were higher or more breastfeeding longer than 12 months. And this is any breastfeeding, I need to mention. Okay, so how to make sense of this massive amount of data to get to something more manageable? So here we took we summarized basically the variance that we saw in all these 450,000 CpG sites, and we constructed little co-methylated clusters. So we did that using principal component extraction, and so a principal component basically summarizes the variance across multiple variables, and in this case, it was several thousand CpG sites. And that gives you basically a new variable. So here are the first, I think it's 7 principal components. And this value you can then correlate with your predictors of interest. And this is exactly the results from this correlation. So what was interesting here, so we have here principal component 4 that was significantly associated with maternal sensitivity at 6 months, but also breastfeeding at 6 months. And I think this is particularly interesting because this principal component 4 is the component that summarizes the 4th largest part of variance across the epigenome. So, of course, we can look at this a bit more in detail, but I think what's important here is that the association remains significant after controlling for different covariates. Also, maternal sensitivity remains significant after controlling for the same variables. However, when we combined breastfeeding and sensitivity, we saw that maternal sensitivity was actually the stronger predictor for DNA methylation principal component 4 as compared to breastfeeding. So breastfeeding was not significant anymore, just sensitivity. When we then look at, well, what is the CpGs that are loading on this principal component, we see here calcium signaling pathway, salivary secretion, but also thyroid hormone synthesis. And I think this last one is interesting because it is strongly involved in metabolism. So I'll skip through the molecular function because what I then continued doing was basically clustering the methylation sites to co-methylated modules, and you get a so using this method you get different color modules. And interestingly, 3 of the modules that we obtained were associated with maternal sensitivity, but another module, the brown module here, was associated with breastfeeding. So, what does that mean? We are currently investigating the specific clusters that came out here. So we have, for example, a transcription factor in this module, in this yellow module. Also, the green module is clustering. Many of the CpGs are related to this transcription factor AP2 beta. Same for the blue module. Here we have some homeobox 5 and 6 genes that are well represented, but also other genes. So here MECOM, for example. When we look at the brown module that has been associated with breastfeeding, there was not a clear cluster of genes that were represented. So I performed a gene ontology enrichment analysis that showed that here the Wnt signaling pathway was enriched. So that means that the Wnt signaling pathway is involved in cell fate and cell patterning during development, carcinogenesis, type 2 diabetes, and inflammation. So I think this really is interesting and warrants further investigation. So to summarize this, maternal sensitivity and breastfeeding were both associated with variants in offspring DNA methylation, but with distinct clusters of CpGs. So where do we go from here? I think I was mostly surprised by the finding that sensitivity seemed to be the stronger predictor of DNA methylation compared to breastfeeding, at least on this principal component 4, which again, I have a picture here of the Harlow experiments. So, but I'm more than happy to discuss your ideas why this might be, especially given that breastfeeding is this very strong biological signal. But I guess you could also say that about maternal sensitivity. Finally, as was already mentioned before as well, epigenetic studies often bring more questions than answers. And I think we have still a couple of difficulties to overcome. For example, parental behavior is a very complex phenotype. So what are we studying exactly? Is DNA methylation a mediator, moderator, or both, depending on gene? What about intergenerational transmission? How is this transmitted to the next generation? Sensitive periods, are there specific time periods that we need to consider? Then, of course, humans are biparental species. So where is the father in all of that story? And finally, are these effects channel or very specific? And with specific, I mean specific to regions on genes themselves, on gives particular populations, and so on. So I think the clinical implications of these are that parental sensitivity has long-lasting effects on infant development and probably also on an epigenetic level, but breastfeeding might have too. So just because this was this result did not hold for this principal component 4, I think breastfeeding still has an impact, maybe just not on this particular source of variation. And then I think the take-home message is like the other presentations. We need to do everything in our power to support parents, to ensure that they have the necessary resources. And here it's not only material resources, but also and especially emotional and social resources that parents need to care after their infants. And with that, I would like to acknowledge a lot of people and groups that particularly those involved in the MAVEN study. And with that, any questions? Otherwise, thanks for your attention.
Thank you very much for a very clear lecture, and the summary at the end I think was really excellent, because there are so many questions that you raise with all these talks, and but we can see the potential of everything here, and that it may lead to better care in the future. I think we have one question from, or several.
Yeah, there is a digital question. It was actually meant for Rosario, but I think it's you can answer it, and it's from your friend Vibeke Jonas, and she writes, "Thank you, Rosario, for a great talk." Thank you, Eva, for a great talk. A comment: I think it's interesting how many of today's parents do not touch their infants in everyday life situations. Babies are placed in a carrier. Do you agree with that, or do you have any reflection on that?
Are you asking me? I think Rosario would be the person to answer that question. But I think, and maybe I can ask another question. What about the parents that are now so very much distracted by their digital devices? I see people strolling their children with looking at screens. And I think it's really important that we have a close interaction with our children, especially during the early years. And this definitely also includes touch. Here I'm talking, of course, about the affectionate touch that has been mentioned previously, because there is also intrusive touch, right, which might not have the same beneficial effects.
Thank you, Eva. It was wonderful. Is it on? Yeah. The same reflection as you did in the end of your talk, that the sensitive caregiving and parenting is almost or even more important than breastfeeding, and we in the society we know that breastfeeding is good. The breast milk is good. It has many good implications for the infant, and we also put a lot of resources to support breastfeeding, but I don't actually see the same resources being put into supporting sensitive caregiving and the touch, the affectionate touch that Rosario is talking about, and skin-to-skin care for sensitive children. So more comment, but yeah, thank you.
Lena?
Oh, okay, Björn.
Thank you very much for a fantastic lecture. I think it was very valuable to listen to. And I also would like to catch on your comments, Stina, because I think actually I'm the only male. No, there are a few males here, a few. And I think it was really very reassuring that sensitivity was more important than breastfeeding. And I will come back to Rosario's lecture as well. He asked what is happening with the mother. But I can tell you something is happening in the father as well. And I think that might be to elicit sensitivity, the breastfeeding, the skin-to-skin contact, early, immediate skin-to-skin contact. And so just a comment.
Do we have any more questions or comments? I cannot see any hands waving. Then we thank you so much for your excellent lectures, and we only have these flowers and a voucher for next year's meeting. Thank you so much.
Thank you very much
For a very thoughtful and interesting lecture. Thank you.